Hello friends, so this question is something related to what is the concentration of 40 ppb of SO2 in microgram per centimeter cube, or we can say microgram per meter cube. So in this particular question we are taking the value as microgram per meter cube and the temperature is 25 degrees centigrade. Okay, so we have to find out the concentration of 40 ppb of SO2 in microgram per meter cube at 25 degree centigrade. And firstly I'll be telling you this short trick, and thereafter I'll be telling you the detailed view, like how we will be arriving at that short trick. If you have to find out the values in microgram per meter cube, so we have to simply take the values in ppb and we have to multiply that with the molecular weight of the species, and SO2 in this case is having a molecular weight of 64 gram per mole, and we have to divide that with 24.47. Now what is 24.47? It is basically the volume of ideal gas at room temperature, means 25 degrees centigrade and 1 atm microgram per meter cube values. So it will come out to be like 40 ppb multiplied by 64 divided by 24.47, and if you do the calculation it comes out to be 104.7 microgram per meter cube. So that's how we will be able to solve this question quite easily. However, there are certain things that we need to understand. So suppose in this question the temperature is changed from 25 degrees centigrade to 40 degrees centigrade, or even the pressure is changed from 1 atm to 2 atm, or even it is changed as 40 ppb to 40 ppm. How will we be solving then? So for understanding these nuances, we need to understand the basics of it. And for understanding the basics, we should first go to understand the ideal gas equation. So you all must have studied the ideal gas equation in your earlier classes, like class 11th and 12th, and it is PV is equal to nRT. Okay, so when we study about this thing, means the ideal gas equation, and we have to find out the volume of an ideal gas per mole. That means we have to find out volume of ideal gas per mole. Then it comes out to be RT by AP, simply shifting the values from left to right and right to left. Okay, and we know that R is basically a gas constant, so that is having value equal to 0.0821 liter atmosphere per mole Kelvin, and temperature is in Kelvin, pressure is in atm. So if we will put all these value for room temperature, okay, so V by N will become 0.0821 liter atmosphere mole Kelvin multiplied by temperature, that is 298 Kelvin, and pressure is 1 atm. Atm to atm cancel, Kelvin to Kelvin cancel, and the value comes out to be 24.47, okay, liters per mole. Right, so that's how we arrive at this number of 24.14. If it is clearly given in your question that the temperature is 298 Kelvin or 25 degrees centigrade and atmospheric pressure is either not given or it is given as 1 atmospheric pressure, then you can simply use this value directly. Okay, however, if the pressure and temperature are changed, then you can find out the V by N simply by putting the values here and here. I hope this is understood till now. Now we have given this 40 ppb. So what does this ppb means? So ppb is basically a unit in volume basis, okay, and the microgram per meter cube is a unit in mass basis. Okay, so it is basically talking about mass, it is talking about volume. Now what does that ppb means? So ppb simply means that 40 parts of a species are there in 1 billion parts. Okay, right? So if we have to understand it simply, we can simply write 40 liters of a gas SO2 here in 10 raised to power 9 liters of air. So 10 raised to power 9 comes from billion. Okay, had it been million, 10 raised to power 6 value would have been used. So 40 liters. Another conversion that you should always remember here is that 1 meter cube is equal to 10 raised to power 3 liters or 1000 liters. Okay, so if we have to find out the value of 1 liter, then 1 liter is equal to 10 raised to power minus 3 meter cube. Okay, and we can use this value directly here in place of liters, and once we will be doing it, the value that we will be arriving at is 40 liter SO2. Okay, so SO2 is having a molecular weight of what, 64 gram per mole, and 1 mole is having a volume is equal to 24.47 liter. So that's how we are arriving here. Okay, then we have to divide that by this number, 10 raised to power 9 liters of air, and 10 raised to power 9 liters. So in place of liter, what we can use is 10 raised to power minus 3 metric cube, right? So this is what we are having. So now what we will be doing is cancelling the liters to liter, and another thing is that 1 gram is having 10 raised to power 6 microgram. So gram will be cancelled to gram. Okay, and we will be remaining with just these numbers. 10 raised to power 6 will be cancelled with 10 raised to power 9 multiplied by 10 raised to power minus 3 will be 10 raised to power 6. Okay, so all numbers are cancelled, and we are just remaining with 40 into 64 microgram divided by 24.47 what, metric cube. And this particular number is nothing but that our magical number that we used previously, which simply says that this is molecular weight and this is the volume of ideal gas. So if we have been given that the temperature and pressure are 25 degrees centigrade and 1 atmosphere respectively, so we can directly use this. Okay, and if those are not the same, then I have told you previously that this value comes out from V by N is equal to RT by P. So simply changing these values, we can arrive at this value. Okay, so I hope I have made myself clear here, and in case you are having any doubt, you can tell me and I'll be more than happy to help you, and comment whether you like this video or not. And in case you're having any doubt, please comment. And if you like my work, subscribe to the channel and share my work, so it motivates me to make more such videos. Thank you.